Good day, I'm Fernando Manalo from ECE42, and today's experiment is stepper motor control, wherein the objective of this experiment is to control the stepper motor direction, speed, angular displacement, and using the Arduino interface. To start the experiment, these are the materials required. The materials needed for this experiment is a 5-volt power supply, the L293D motor driver shield from Adafruit, 5-volt stepper motor, and Arduino 2560 Mega, and of course a computer. Now I will explain the code that will be used in each experiment. In the interface code, we have to create a program that will send a character A if you press clockwise button, send character B if you press the counterclockwise button, and send character C. However, in this case, we will be using the Arduino serial monitor, wherein if we enter A, B, or C, it will do the same processes. And to start, let us zoom in, and first we include the AF motor.h, which is the Adafruit motor shield that I am using, which uses the L293D motor driver. Set a character for letter, which will be used later for the character input. Serial.begin begins the serial monitor, and motor.setSpeeds will set the RPM of the stepper motor to 15. Now in this loop, if serial available is greater than 0, the loop will run code only when a character is entered, and depending on the character entered, if A is selected, the motor will run forward using motor.step 2038, which corresponds to the one full revolution forward and single coils. If B is backward, and C will stop. For the next part, the number 2, for the stepper speed control, the same thing, but in this case we will be using the int speed variable, wherein we will be entering a speed of 0 to 15 and using the constraint so that the values will be from 0 to 15. And then in this loop, motor.setSpeed, and then after the loop is finished and no character is entered, the entered speed will then be used by the motor.steps forward single, and then it will change the speed of the stepper motor. For the third part, is to create a code for the program that will send integer value that correspond to the number of steps the motor will take. Same library AF motor.h. Now we will set the speed to constant 15. Since in this case we will only be changing the steps. Now this is the serial monitor prints. And set speed is constant to 15 RPM. Now in the loop section, serial.parsit gets the value entered, wherein the steps can be 1 to 2038. As 2038 corresponds to 1 revolution, and then the motor runs using the motor.step steps forward and single. Now we will go to the actual simulation using the code and the actual circuit assembly. Now we will start for the stepper direction control using this code, and I will connect my Arduino to the computer. And then upload my code. Now it's done uploading. Now I have to plug my 5-volt power supply. it's already plugged. Now let us open the serial monitor, and as you can see, it's stepper motor direction control. Select A for clockwise, B for counterclockwise, and C to stop. Now I will first select clockwise, which is A, and we can see I'll put the motor here. I'll enter A, and the stepper motor is moving clockwise. Now we will stop it and see. Now the motor is not moving, and then we will enter the reverse, which is B, or counterclockwise, and now the stepper motor is moving clockwise. Therefore, our my stepper direction control code and interface to the Arduino is working properly. The next part of the experiment is the stepper motor speed control, and here's my code, and I've already connected my Arduino. Now I will upload the code to my Arduino. Now it is done uploading. In this speed control, this program controls the stepper motor speed using Arduino Omega P60 and Adafruit Motor Shield version 1 L293D. Now I will open the serial monitor, and as you can see, stepper motor speed control, and the maximum rotations per minute based on the datasheet of this kind of stepper motor is around 15 revolutions per minute. So first we will enter 15, which is the maximum, and now it's turning 15 times per minute. And if I enter 10, now it's moving slower. If I enter 5, now it's even slower. And let's try, let's say 2 revolutions per minute. Now it's moving super slow. And then let us try 8. Now the motor is moving a little bit faster, and therefore I can conclude that my code and my setup is working properly for the Arduino stepper motor speed control. Now for the third and last part of the experiment, which is the stepper motor steps control, or the angular displacement of the motor. Here is my code, and the maximum steps per revolution is 2038. Since this motor has a gear ratio of 1:64, and the stated steps per revolution is 32, so 32 times 1 is for 1:64, then we multiply it is around 2038. Now I will upload the code, and as you can see, the stepper motor is not moving. And here is the serial monitor output. We will enter 12038. Now I will enter 2038 for 1 revolution. And it successfully ran the 1 revolution. Now let us try half a revolution, which is 1019. Which is 180 degrees, half the revolution. Now let's say a random number, let's say 500 steps, 100 steps, 200, 300, 400, 500, and Now we can conclude that my code and my setup is working properly for the stepper motor step control. And that's the end of today's experiment. And as you can see, we have successfully interfaced our microcontroller and stepper motor using the Adafruit Motor Shield version 1. And we have successfully controlled the direction, the speed, and the angular displacement or the steps that the motor will take and interface it to the Arduino serial port. And that's the end of today's experiment, and thank you.